the NDA of a line capital AB is in HP and 25 mm in front of VP. The end capital B is 10 mm in front of VP and 50 mm above HP. The distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. Draw the projections of the line capital AB and determine its true length and true inclination with HP and VP. So here he says the NDA is in HP. So when you look from the front view, the NDA will going to fall on the horizontal plane. That image will going to be seen in the vertical plane. So that will going to be small a dash. And 25 mm in front of VP. So in front of VP is seen in HP. So when you look from the top view, we can see the distance in front of VP, which is 25 mm. Similarly, the NB is 10 mm in front of VP. So when you look from the top view, we can see the distance in front of VP, which is 10 mm. And then draw a horizontal line, a horizontal dashed dot line, and you mark that as the locus of B. The locus of B means where the top view of the point B and the top view of the true length B2 should lie on that particular line. And 50 mm above HP. So 50 mm above HP is seen in the vertical plane. You can see from XY line, you draw a horizontal dashed dot line which will be 50 mm above HP, and you write this as the locus of B in the front view. So the distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. So from this end projector A, you measure the distance of 80 mm and you draw a vertical projector such that it will going to cut the locus of B in the front view, and you mark that point as B dash, then join A dash B dash with a dark line. Similarly, in the top view, you from the end projector A, you measure the distance of 80 mm because the distance between the end projectors in front view and top view will be same. So here from this point you draw a vertical line so that it will going to cut the locus of B in the top view. So that point will going to become small b, and when you join, both will going to be on the both B dash and B will going to be on the same line. Then join between A and B with a dark line, which will going to be the top view. Now we need to find out we need to determine the true length and its inclination with HP and VP. Now first we need to find we need to project the top view. We need to project the actual line in the space. So from B you draw a vertical projector, and also from B dash you draw a horizontal projector. Both will going to meet at this particular point, which is capital B. So that means the distance between the end projectors is 80 mm, that is the horizontal distance. Now the vertical distance will be 80 mm above 50 mm above HP and 10 mm in front of VP. So this point, that is capital A and B, which is the line which is going to be in space. Now first we will going to find out the true length in the vertical plane. If you want to find the true length in the vertical plane, the line has to be parallel to VP. So with A as center, take the radius of AB, you rotate such that B will also be in front of VP by 25 mm. So that the NDA is also in front of VP by 25 mm, and also the NB is also, that is NB1 is also in front of VP by 15 mm, that is 10 mm, I mean 25 mm. So that both B1 will be in front of VP by 25 mm. So that in front of VP can be seen in horizontal plane, that is when you are projected. So you are going to see both AB1 will be parallel to VP. So since this line is parallel to VP, and that means this line is parallel to VP, when you look from the front view, that image will going to fall on the vertical plane. That is when B1 is projected onto the locus of B, you are going to get this B1 dash, then join A dash B1 dash with a little bit thicker than the projector line. So we are going to get this. So when you are rotating the point capital B in space, then what happens? That B in the top view is rotated such that AB1 will going to be parallel to VP, and then when you projected this onto the XY line and then you draw a vertical projector such that it will going to cut the locus of B in the front view. So you are going to get this point as B1 dash, then join A dash B1 dash with a little bit darker than the projector line. So this will going to be the true length, and its inclination measured with respect to HP will going to become theta. Now we will going to consider the true length in HP. So the true length in HP means the line has to be parallel to HP. So now here with capital A as center, you take the radius of capital AB, you rotate that B such that B will also rest on HP. Now at present the B is above HP by 50 mm. So that B also has to rest on HP such that the B is in front of VP by 10 mm. So with A as center, by taking the radius of AB, you rotate such that the B moves in the horizontal plane. It will not move with respect to the vertical plane. With respect to the vertical plane, it is in front of VP by 10 mm. So that is the reason why the capital B, that is the top view B which was here, will move to this particular point. So in this case, when you are rotating in space with B from B2, that is from above HP by 50 mm to on HP, so that it will going to become parallel to HP. So what happens to the image? The image in the vertical plane will also be get rotated. So that means, so from B dash, which has been rotated such that B2 dash will going to come on the XY line. That is, when you look from the top, when you look from the front view, the B2 will be projected onto the XY line. So that it will, because B2 is on HP, so B2 dash will also be on HP. Because A dash is on HP, so A dash B2 dash is the line which is parallel to HP. Since this line is parallel to HP, so we can see that it is the true length in HP. So we got AB2. Join AB2 with a little bit darker than the projector line. So this will be, since this line is parallel to HP, we mark this as A and capital B2. So this is how we will be able to get the true length with respect to the HP, and the inclination made by this with respect to VP is called phi. So determine that particular angle. So this is how we will be able to analyze in the 3 dimension. Now we will go to solve by using the sketchbook. So first we will go to draw the XY line and mark XY and VP HP. So we says that NDA is in HP, so obviously that will be on XY line in the front view. So you mark that point as A dash, and then 25 mm in front of VP. In front of VP will always come below XY line because HP is below XY line. From A dash, you measure the distance of 25 mm and draw a horizontal line. So you project from A dash to this projected line, so that horizontal line, so that you will going to mark that point as small a. So that is A is in front of VP by 25 mm. Then the NB is 10 mm in front of VP. In front of VP is always seen in HP. So from the XY line you measure 10 mm below XY line and draw a horizontal dash dot line and write that as the locus of B in the top view. Similarly, 50 mm above HP, 50 mm above HP is seen in the vertical plane. So from XY line you measure 50 mm above the XY line because VP is above XY line and draw a horizontal dash dot line which will going to be the locus of B in the front view. Then he says the distance between the end projectors when measured parallel to the line of intersection of HP and VP is 80 mm. From A dash you measure the distance of 80 mm and draw a vertical projector which will going to cut both the locus in the front view and as well as in the top view, so that you will going to get in the front view it is B dash and in the top view you will going to get B. Then join A dash B dash with a vertical dark line and A to B with a dark line. So A dash B dash will be the front view because the top view of that point AB is inclined. AB will going to be the top view because the front view of that line is inclined. Now we need to find the true length. So to find out the true length, first we will going to consider the true length in VP. So to find the true length in VP, so we have to rotate the line which is inclined to VP. So which is the line which is inclined to VP? That is the top view line which is AB, which is inclined to VP. So with A as center, by using the compass, you measure take the radius of AB and rotate it such that B1 is also in front of VP by 25 mm, so that the top view of the line AB1 will be parallel to VP. Since it is parallel to VP, then it will be, the true length will be found in the vertical plane, that is in VP. So when you project this A is already, which has been marked here, which is A dash, and B1 which is here, in the front view B1 dash is not there, so you draw a vertical projector from B1 to the locus of B in the front view, so that it will going to cut the locus of B which is here B1 dash. So that means the B1 it will going to rotate only with respect to the vertical plane. With respect to HP it will going to remain the same. So that is the reason why which was B dash which was initially here, which has been shifted to B1 dash. That means the distance with respect to above HP will going to remain same. So that is the reason why it moves in B dash to B1 dash. So B1 dash will going to be the point which will going to be the true length point in the front view. Join A dash B1 dash with a little bit thicker than the projector line. So the inclination made by that with respect to HP is called theta. So since AB1 is parallel to VP, so A dash B1 dash will be in true length. So you mark this as capital A and you mark this as capital B. Now we will going to take up the true length in HP. The true length in HP means it should be parallel to HP. So which is the line which will going to be parallel to HP? The line which is inclined to HP. The line which is inclined to HP is A dash B dash. With A dash as center, take the radius of A dash B dash and you draw an arc such that A dash is in HP. So B2 dash will also comes on HP. But the distance with respect to VP will going to remain the same. You can see initially the point was B here. So it will be moved to B2. So that means since A dash B2 dash is the line which is parallel to HP, so we are getting the true length in HP. So join A to B2, A and B2 with a little bit thicker than the true line, little bit thicker than the projector line. So since A dash B2 dash is the line which is parallel to HP, so we are getting the true length in HP. So we will mark this as capital A and mark this as capital B. So the inclination made by this line with respect to VP is called phi. So this is the phi. So by using the scale, you measure the length of the true length, which will be same in both in the front view and as well as in the top view, which will be 95.52 mm when you are doing it in computer. When you are doing it in manual, it will be 96 mm. And the true inclination with respect to HP is measured by using the protractor. Then the theta will be 31.56 when you are doing it in CAD. When you are doing it in when you are doing it in manual, it will be 32 degrees. Similarly, the true inclination made by this with respect to VP, which will be phi, which will be 9.03 when you are doing it in CAD. When you are doing it in manual, it will be 9 degrees. So this is how we will be able to solve the problem in the orthographic view in the sketchbook. Now we will going to analyze it in step by step. So here in the step by step, first we will going to consider, so the line is on HP and in front of VP by 25 mm, and then the point B is above HP by 50 mm and in front of VP by 10 mm, and the distance between the end projectors is 80 mm. So when you draw this, it will going to cut the point at B and also be both the top view and as well as the front view. Since we are considering only the top view, now we have erased that. With A as center, by taking the radius of AB, you rotate it such that you make it parallel to VP. So AB1, which is parallel to VP, you can see that A to B, when it is rotated, it will be parallel to VP, AB1. So when it is projected onto the horizontal plane, you will going to get small AB1, which is parallel to AP. This line and this line is the same. So now when you are projected this into the front view, you are going to get the true length in VP. So now we are getting that also here, it is true length in VP. So this line is true length because AB1 is parallel to VP. Because AB1 is both are in front of VP by 25 mm. So that is the reason why we have marked this as capital A and capital B. So this is the true inclination with respect to HP, which is theta, which is measured here, and also the true length. Now we will go to the next true length in HP. So the true length in HP means the line which is to be parallel to HP. So that in the, now we have considered the front view. The front view line has to be rotated. You make A dash is on HP, so B2 dash is also on HP. So A dash B2 dash is the line which is parallel to HP. So when it is projected onto the locus of B, you are going to get the true length in HP. So this will going to be capital A and this will going to be capital B. So the inclination made by this with respect to the vertical plane, which can be seen in HP. So this is the angle which is phi, which is determined by using the protractor, and also by using the CAD we can get this particular value. And the true length is there in the front view also, it is 95, in the top also it will be 95. So this is in the 3 dimension. When capital A with the dot as center with AB as the radius, you rotate it such that only it is reduced with respect to HP, but with respect to VP it remains the same. That is the top view which was here, which moved to B2, so that it is parallel to HP. Since it is parallel to HP, that is A dash B2 dash is the line which is parallel to HP. So its corresponding length here in the top view will going to be in true length. And the inclination made by this is the angle phi, which has been measured by using the protractor. This is how we will be able to solve the problem in step by step.